talk about polygons. In your book, you're going to see all these words. And remember what I said about your book? All the answers are where?
Online.
No, not the homework answers. Just like when you're in the reading. Before you look things up, read carefully. So I guess they're in the reading and also I post them. But there's a lot of words here that you have to understand. Okay? So they're in your book. You don't have to write all this down, but we're going to talk about some different things here. I know you know what a polygon is in visual, but can anybody tell me what a good definition is, Tyler?
A shape with sides that all touch and there is no curve.
That's a bunch of polygons all put together.
So, a shape with sides that all touch and there's no curves. I'm just trying to think if I can ruin that a little bit.
Yeah, as if they cross.
You could ruin it by just drawing a right angle.
Well, technically, so for example, that's not a great example. This is would you say that what I just drew here is a polygon?
No.
Do all the sides touch?
Yes.
Okay. So maybe we could do better than that. So when you do definitions, sometimes a better way to think about a definition is to think of examples and non-examples. Okay? So we would then include, all right, we would then include this
You should just keep that down.
to be a non-example. But I know Tyler knows what a polygon is. And he did say there's no curves, right? So let's try again, yeah.
All the lines close and don't cross. It's a closed shape.
It's a closed shape.
They don't cross.
So it is a closed shape, right? So this would not be a polygon because it's not a closed shape. And we're going to not really talk about lines, we're going to talk about segments. Okay, so a little better, Ethan.
Has to be 2D.
So it's a two-dimensional closed figure. What else? Yep. No intersections? Well, here's an intersection.
No, through intersection. Like a street
Through
intersection.
Okay.
You
Mike,
say with more than two sides.
has to have more than two sides. Where are the answers?
In the reading.
In the reading. Okay, so look at page 54. This is kind of a guided reading exercise. So you're right, Mike. It has to have at least three sides. Can we do this more efficiently?
Whoa, that's a lot.
So you guys hit on it. Closed figure. Sides are line segments. We know that we don't want them to overlap, so how do we say that, Will?
A polygon is a closed figure in plane formed by a connected line segment and endpoint.
Okay. So he found it in the reading. He did just what I asked him, but we did say it has to be in a plane, right? So it has to be a plane figure, closed figure. So what else do you remember reading? Whose sides are segments connected endpoint to endpoint. You see the definition?
Yeah.
Okay, so we're not going to write all these down because these are things in your book. What page is that on?
54.
Page 54. But when you go through the reading tonight, take time to think about the reading, but think in terms of examples and non-examples. You know, so of course there's so many examples. This is a polygon if these were really straight lines, right? Let me get rid of that little bit. That's a polygon. So it just has to have segments for sides that are connected endpoint to endpoint. And it has to be in one plane. What are you boys doing?
it. It's what?
Okay. What about regular polygons? What makes a polygon regular? Without looking in your book, what do you know from before? Examples and non-examples. Curtis.
Equal sides.
Equal sides, that's one thing. Somebody else besides Ethan. David.
Equal angles?
Yeah. So how can we make the definition? Remember you have to classify it, so Ethan, how would you classify it? A figure is a figure is a regular polygon.
If it has equal sides and congruent angles.
Yeah, so the word regular, a figure is a regular polygon if, and now we're going to distinguish it. Remember, you classify and then you differentiate. How is it different from all polygons? It has equal all sides and all angles are congruent. Okay, so again, examples and non-examples help you kind of think about that. Most people, oftentimes I would say people think rectangles are regular. But
They're regular.
because they look kind of symmetrical, right? But what's wrong with it?
It doesn't have equal sides.
It doesn't have equal sides. So by going to the definition, you can tell what's wrong with it.
I almost think in elementary school they said that rectangles were equal.
In elementary school, it's something you go to a lot, and so they use it for a lot of symmetry examples. And so I think then you start to feel like it's regular because it's pretty symmetrical, you know, but it doesn't meet the requirement. So it's not okay. I wanted to talk about, not this right now, but who knows what convex and concave is?
Oh, me.
Okay. Oh, shoot, I have to practice. Ben,
Alright.
which one of those is convex and which one is concave? Yes. How do you think of that? Okay, so but an equilateral triangle has acute angles, right? So, and these are convex over here. These ones are convex, and this is concave. So it's not really a good enough way to think about it. What else?
So convex is it curves outward and concave is it curves inward.
There's no curves.
Oh,
They're polygons, Logan.
Well, I got sort of going off the lines go inward.
Yeah, so a lot of times we think of things caving in, which is a good way to think about it. It's not a good enough definition. So the way you would define it is you would use diagonals. Do you know what a diagonal is? What's diagonal, Ethan?
It's a line that connects two of the things on the polygon that are not connected by another line.
Right, it's a line that connects two vertices on a polygon that are not adjacent. So like, let me do that. Go away. Okay. So, so this is a diagonal. And that's a diagonal because it's a segment, a line segment, and it connects vertices that are not next to each other, so not consecutive. So on here's a diagonal. And here's another one, and this diagonal is outside, right? Because of the shape caving in. So if your diagonals cannot be all drawn inside, it's concave. We're going to stop there.